Now let us deal with zeros of a polynomial. A real number a is a zero of a polynomial p of x if p of a is equal to 0. That is, when a real number a is substituted in a polynomial, if the polynomial becomes equal to 0, then we call the value of x as the 0 of a polynomial. We should remember here, if a real number a, if substituted in a polynomial, if that polynomial doesn't equal to 0, then it is not a 0 of a polynomial. And in this case, a is also called a root of the equation p of x is equal to 0. If this is equal to 0, p of a is equal to 0, then a is called as the root of the equation and it is also called as the 0 of the polynomial. If p of a doesn't equal to 0 means then a is not a root and it is also not a 0 of a polynomial. Find the value of the polynomial p of x is equal to 5x square minus 3x plus 7 at x is equal to 1. So here p of x is equal to 5x square minus 3x plus 7 at x is equal to 1. So let us substitute x is equal to 1. So p of 1 is equal to 5 into 1 whole square minus 3 into 1 plus 7. So it will be equal to 5 into 1 minus 3 plus 7. So here 5, this is plus 7 minus 3 means plus 4. So the value of p of 1 is equal to 9. Find the value of the polynomial p of x is equal to 4x to the power 4 plus 5x cube minus 3x square plus 6 at t is equal to a. So here p of x is equal to 4x to the power 4 plus 5x cube minus x square plus 6. X is equal to a. Here x is equal to a. So p of a is equal to 4a to the power of 4 plus 5a to the power of cube minus a square plus 6. For these examples, we can come to the conclusion that p of 1 is equal to 9 in the first case, and in the second case p of a will be equal to 4a to the power of 4 plus 5a cube minus a square plus 6. In both these cases, this value of x is equal to 1 is not the 0 of the given polynomial in this first example, and in this second example a is not the 0 of the given polynomial p of x. Likewise, we can also say that x is equal to 1 is not the root of the given polynomial. In the second problem, x is equal to a is not the root of the polynomial p of x is equal to 4x to the power 4 plus 5x cube minus x square plus 6. Find the value of q of y is equal to 3y cube minus 4y plus root of 11 at y is equal to 2. So let us substitute the value of y in the polynomial q of 2. So as y is equal to 2 is equal to 2 cube minus 4 into 2 plus square root of 11. So q of 2 is equal to 3. 2 cube is equal to 2 into 2 into 2, which is equals to 2 cube is equal to 8. So 2 into 8 minus 4 2s are 8 plus root 11. So q of 2 is equal to 8 3s are 24 minus 8 plus root 11. So q of 2 is equal to 24 minus 8 is equal to 16 plus root 11. This is the value of this polynomial. Q of 2 is equal to 16 plus root 11. So that we can say that y is equal to 2 is not the root of this polynomial, and also we can say that y is equal to 2 is not the 0 of the given polynomial. Q of y is equal to 3y cube minus 4y plus root of 11. Q of 2 is equal to 16 plus root 11. 16 plus root 11 is the value of the given polynomial at y is equal to 2. Find the value of the polynomial 5x minus 4x square plus 3 at x is equal to 0. The second case is x is equal to minus 1, and third case is x is equal to 2. So let me begin with 5 of 5x minus 4x square plus 3. So as x is equal to 0, what happens here is 5 into 0 minus 4 into 0 whole square plus 3. So 5 into anything is 0 minus 0 square is 0. 0 into 4 is also 0 plus 3. So the answer is 3. Whereas here the polynomial can be written as p of x is equal to 5x minus 4x square plus 3. So as x is equal to 0, p of 0 is equal to 5. So x is equal to, here x is equal to minus 1. So p of minus 1 is equal to 5 into minus 1 minus 4 into minus 1 whole square plus 3. So here 5 into minus 1 is minus 5, minus 4 into minus 1 whole square, minus 1 whole square is equal to minus 1 into minus 1, so which is equals to minus into minus is plus 1. So here plus 1 plus 3. So here it will be equal to minus 5 minus 4 plus 3. So minus 5 minus 4 is minus 9, minus 9 plus 6 is minus 6. So p of minus 1 is minus 6. Likewise, here also p of x is equal to 5x minus 4x square plus 3. So x is equal to 2. As x is equal to 2, p of 2 is equal to 5 into 2 minus 4 into 2 whole square plus 3. So 5 2s are 10 minus 4 into 2 square is 4 plus 3. So 10, 4 4s are minus 16 plus 3. So minus 16 plus 10 is minus 6 plus 3. So p of 2 is equal to minus 3. Here also we can say that x is not the 0 of this polynomial. X is equal to 0 is not the 0 of the polynomial. And in this case also we can say minus 1 is also not the 0 of the polynomial, as p of minus 1 is minus 6. And here x is equal to minus 2 is also not the root or the 0 of the polynomial of the given polynomial. And we can say that 3 is the value of the polynomial at x is equal to 0. And here minus 6 is the value of the polynomial at x is equal to minus 1. Likewise, minus 3 is the value of the polynomial at x is equal to 2. Find p of 0, p of 1 and p of 2 for each of the following polynomials. Firstly, I have taken p of y is equal to y square minus y plus 1. So, first case is y is equal to 0. That is, p of 0 is equal to 0 square minus, substituting the value y is equal to 0. So, p of y, in place of y we should write 0. Likewise, in place of y we are writing 0 square minus y. So, 0 plus 1. So, p of 0 is equal to 0 square is 0 0 minus 0 plus 1, that is P of 0 is equal to 1. In the second case, P of 1 we should find, that is y is equal to 1. So P of y, we already know P of y is equal to y square minus y plus 1. So y is equal to 1 means what happens here? P of 1 is equal to 1 square minus 1 plus 1. Here we can cancel minus 1 and plus 1. So P of 1 is equal to 1. This is the value of the polynomial. 1 is the value of the polynomial at y is equal to 1. And let us move on to the second polynomial, second case, that is we want to find P of 2, that is P of 2, that is y is equal to 2. P of y is equal to y square minus y plus 1. Y is equal to 2. So P of 2 is equal to y square, 2 square. Here in place of y square we should write 2 square minus, in place of y we should write 2 plus 1. So P of 2 is equal to y, 2 square is 4 minus 2 plus 1. So P of 2 is equal to 4 minus 2 is 2 plus 1 is 3. So P of 2 is equal to 3. P of t, second case, is equal to 2 plus t plus 2t square minus t cube. In the same way, at t is equal to 0, P of 0 is equal to 2 plus t. In place of t we should write 0 plus 2 into 0 square minus 0 cube. So here 2 plus 0 plus 0 square is 0, 0 into anything is 0 minus 0. P of 0 is equal to 2. Straightly we can write as in the second case P of 1. So let me write t is equal to 1. T is equal to 1. P of 1 is equal to 2 plus, in place of t we should write 1 plus 2 into 1 whole square minus 1 cube. So P of 1 is equal to 2 plus 1 is 3 plus 2 into 1 square is 1 minus 1 cube is 1. So P of 1 is 3 plus 2 minus 1. So P of 1 is equal to 3 plus 1 is 3 plus 2 is 5. 5 minus 1 is 4. P of 1 is 4. Next step is t is equal to 2. P of 2 is equal to, from this equation, 2 is as it is 2 plus t. In place of t we should write 2 plus 2 into t square. T square is 2 whole square minus t cube. T cube means 2 cube. 2 cube. Here P of 2 is equals to 2 plus 2 plus 2 into 2 square. 2 square is 4 minus 2 cube is, 2 cube can be written as 2 into 2 into 2, which is equals to 2 into 2 into 2 is equal to 8. So 2 cube is 8. So in place of 2 cube we will be writing 8 here. P of 2 is equal to 2 plus 2 is 4 plus 2 4s are 8 minus 8. Here plus 8 minus 8 cancels. P of 2 is equal to 4. So after solving this problem in 3 cases, the value of the polynomial p of t at t is equal to 0 is 2. In the value of the polynomial p of t at t is equal to 1 is equal to 4. In the third case, we can write the value of the polynomial p of t is equal to 2 plus t plus 2t square minus t cube is 4 at t is equal to 2. Here in the first case, p of x is equal to x cube. For x is equal to 0, p of 0 is equal to 0 cube, which is equals to 0. So p of 0 is equal to 0. In the second case is x is equal to 1. P of 1 is equal to 1 cube is equal to 1 cube is 1. P of 1 is equal to 1. In the third case, x is equal to 2. P of 2 is equal to 2 cube is equal to 2 cube means 2 2s are 4, 4 2s are 8. So P of 2 is equal to 8. So the value of the polynomial p of x is 0 at x is equal to 0. And we can say the value of p of x is 1 at x is equal to 1. And the value of p of x is equal to x cube. The polynomial is 8 at x is equal to 2. Likewise, for the fourth problem, we can take x is equal to 0 means p of x can be written as p of 0 is equal to 0 minus 1 into 0 plus 1, as we have replaced x by 0. So p of 0 is equal to minus 1 into plus 1. So p of 0 is equal to minus 1 into plus 1 is minus 1. And in the second case, x is equal to 1. P of 1 is written as 1 minus 1, as instead of x we have written 1 minus 1 into, in place of x we have to replace 1 plus 1. So p of 1 is equal to 1 minus 1 is 0 into 2. So 0 into anything is 0. So 0. So p of 1 is 0. And x is equal to 2. So p of 2 is equal to 2 minus 1 into 2 plus 1, which can be written as p of 2 is equal to 2 minus 1 is 1 into 2 plus 1 is 3. P of 2 is equal to 3. So we can conclude that the value of the polynomial p of x is equal to x minus 1 into x plus 1 is minus 1 when x is equal to 0. And the value of the the polynomial p of x is 0 when x is equal to 1. Likewise, the value of the polynomial p of x is equal to x minus 1 into x plus 1 is 3 when x is equal to 2. Verify whether the following are zeros of the polynomial indicated against them. The first problem is p of x is equal to 3x plus 1 at x is equal to minus 1 by 3. So x is equal to minus 1 by 3. So p of minus 1 by 3 is equal to 3 into, in place of x we should write minus 1 by 3 plus 1. So here 3 is ones, 3 ones, as it is in the numerator and this one in the denominator. So what happens? So 1 into minus 1 is minus 1 plus 1. So p of minus 1 by 3 is equal to minus 1 plus 1 cancels. So the answer is 0. Therefore 0 is the sorry x is equal to minus 1 by 3 is the 0 of the polynomial of the polynomial p of x is equal to 3x plus 1. This we can say that the value of the variable which makes the polynomial equals to 0 is called as the 0 of the polynomial. That means the value of the variable which makes the polynomial vanish, that is which makes the polynomial equal to 0 is called as the 0 of the polynomial. Let's take the second problem. P of x is equal to 5x minus pi, x is equal to 4 by 5. So x is equal to 4 by 5. P of 4 by 5 is equal to 5 into 4 by 5 minus pi. Here 5 cancels. So P of 4 by 5 is equal to 4 minus pi, which is not equal to 0. Therefore, we can say x is equal to 4 by 5 is not the 0, of the polynomial. Polynomial p of x is equal to 5x minus pi. Here, the third problem is p of x is equal to x square minus 1. And the x is equal to 1 and minus 1. There are two cases here. Firstly, let me consider x is equal to 1. So, p of 1 is equal to 1 square minus 1. P of 1 is equal to 1 square is 1 minus 1. So, p of 1 is equal to 0. Therefore, x is equal to 1 is the 0 of the polynomial p of x is equal to x square minus 1. And let us take the second case, x is equal to minus 1. P of x is equal to x square minus 1. So p of minus 1 is equal to minus 1 whole square minus 1. P of minus 1 is equal to minus 1 whole square is minus 1 whole square is equal to minus 1 into minus 1. So minus into minus is plus. 1 1s are 1. Minus 1 whole square is equal to plus 1. Plus 1 minus 1. So P of minus 1 is equal to plus 1 minus 1 is equal to 1 minus 1 is 0. So likewise these two cancel. So P of minus 1 is equal to 0. Therefore, x is equal to minus 1 is also the 0 of the polynomial p of x is equal to x square minus 1. Problem, p of x is equal to x plus 1 into x minus 2 at x is equal to minus 1 and x is equal to 2. Firstly, we will consider x is equal to minus 1. So, p of minus 1 is equal to minus 1 plus 1. In place of x, we have wrote minus 1. And likewise, in place of x, we should write minus 1. Minus 1, minus 2. So, the value is minus 1 plus 1. So, these two cancels. So, it will be equals to 0 into minus 3. P of minus 1 is equal to 0. Why means 0 into anything is 0. Therefore, x is equal to minus 1 is the 0 of the polynomial p of x is equal to x plus 1 into x minus 2. Let us move on to the second case. x is equal to 2. So the case is p of x is equal to x plus 1 into x minus 2. So p of 2 is equal to 2 plus 1 into 2 minus 2. P of 2 is equal to 2 plus 1 is 3. 2 minus 2 is 0. So P of 2 is equal to 0 into anything is 0. So you can say that x is equal to 2 is the 0 of the polynomial p of x is equal to x plus 1 into x minus 2. P of x is equal to x square. At x is equal to 0, at x is equal to 0, p of 0 is equal to 0 square. So 0 square is nothing but 0. Therefore, x is equal to 0 is the 0 of p of x is equal to x square. Likewise, let us solve the sixth problem. At x is equal to minus m by l. The p of x is p of minus m by l is equal to l into, in place of x, we should write minus m by l plus m. So what happens here? L is there in the denominator, whereas l is there in the numerator, minus m plus m. So p of minus m by l is equal to 0, as minus m plus m cancels. So therefore x is equal to minus m by l is the 0 of the polynomial p of x is equal to lx plus m. The next problem is p of x is equal to 3x square minus 1 at x is equal to minus 1 by root 3, and the second case is x is equal to 2 by root 3. Let me take the first case. X is equal to minus 1 by root 3. So p of minus 1 by root 3 is equal to 3 into minus 1 by root 3 whole square minus 1. So this equals to 3 into minus 1 whole square by root 3 whole square minus 1. So equals to 3 into minus 1 whole square is minus 1 into minus 1 is equal to minus 1 whole square, which is equals to minus into minus is plus 1 1 is 1. So minus 1 whole square is plus 1. So plus 1 by root 3 whole square. Root 3 whole square is equal to root 3 into root 3, which is equals to 3. Root 3 into root 3 is 3. So 3 minus 1. 3 cancels. So the value is plus 1 minus 1. So p of minus 1 by root 3 is equal to 0. Plus 1 minus 1 cancels. Therefore, x is equal to minus 1 by root 3 is the root of p of x. Let us now consider the second case. X is equal to 2 by root 3. So p of 2 by root 3 is equal to 3 into 2 by root 3 whole square minus 1. So 3 2 square by root 3 square minus 1, which is equals to 3 2 square is 4 root 3 square, as it is here, 3 minus 1. So 3 cancels. So which is equals to 4 minus 1, which is equals to 3. Therefore, p of 2 by root 3. Therefore, x is equal to 2 by root 3 is not the root of the polynomial p of x. P of x is equal to 3x square minus 1. Now let us move on to the next problem. P of x is equal to 2x plus 1, where x is equal to 1 by 2, x is equal to 1 by 2. So P of 1 by 2 is equal to 2 into, in place of x we should write 1 by 2 plus 1. So 2 cancels here, 1 plus 1 is equal to 2. That is P of 1 by 2 is equal to 2. Therefore x is equal to 1 by 2 is not a root of the polynomial P of x is equal to 2x plus 1. We can also say x is equal to 1 by 2 is not a zero of the polynomial P of x is equal to 2x plus 1. Here also, in this case also, we can write, instead of root, we can write is not a zero of P of x. Here also we can say 0 of the polynomial P of x is equal to 3x minus 1. Find the 0 of the polynomial in each of the following cases. First case is P of x is equal to x plus 5. To find the 0, let us assume P of x is equal to 0. That is, therefore, what happens means x plus 5 is equal to 0. So, x is equal to minus 5 is the 0 of P of x. Let us move on to the second problem, that is P of x is equal to x minus 5. So, here also P of x is equal to 0. Therefore, x minus 5 is equal to 0. So, x is equal to, when this minus 5 shifts to the right hand side, its sign changes, that is plus 5, is the 0 of P of x. Let us move on to the third problem, that is P of x is equal to 2x plus 5. As we already know that P of x is equal to 0, we should find the value of x for which P of x is equal to 0. So, here 2x plus 5 is equal to 0. As P of x is equal to 0, we equated to this one, so it will be equal to x. 2x plus 5 is equal to x. So, 2x is equal to minus 5. So, x is equal to minus 5. When cross multiplied, it comes to the 2 comes to the numerator of the RHS. So, x is equal to minus 5 by 2 is the 0 of P of x. Let us move to the fourth problem, that is P of x is equal to 3x minus 2. Here also x value has to be found for which P of x is equal to 0. So 3x minus 2 is equal to 0. 3x is equal to, when this minus 2 shifts to the RHS, its sign changes, that is will be equal to plus 2. X is equal to 2, and when this moves to the right hand side, when cross multiplied, that will be equals to 2 by 3. So x is equal to 2 by 3 is the 0 of the polynomial P of x is equal to 3x minus 2. Likewise, we can calculate the value of the zeros of all the polynomials. The fifth problem is P of x is equal to 3x. We have to find the value of x for which P of x is equal to 0. P of x is equal to 0. So, 3x is equal to 0. As P of x is equal to 0, 3x is equal to 0. So, the value of x is equal to 0 by 3. That is, x is equal to 0. Therefore, x is equal to 0 is the 0 of p of x is equal to 3x of the polynomial p of x is equal to 3x. Here, in this case, here too, we have to find the value of x, that is the 0 of the given polynomial p of x is equal to kx, for which the polynomial will be equal to 0. P of x is equal to 0. So, therefore, ax is equal to 0. It is already stated that a is not equals to 0. That means x is equal to 0 by a, as in this case, x is equal to 0 by 3. So we can say that x is equal to 0 is the 0 of the polynomial p of x is equal to ax. Problem of this exercise 2.2 is to find the value of x for which the polynomial vanishes. That is, we have to find the 0 of the polynomial. So, p of x is equal to 0. Therefore, cx plus d is equal to 0. So, cx is equal to, when this d shifts to the RHS, it will be equals to minus d. So, x is equal to minus d by c is the 0 of the polynomial p of x is equal to cx plus d, where as per the question, c is not 0 and c and d are real numbers. So this completes this exercise. Non-zero constant polynomial has no zeros. It can never be equated to 0. For example, p of x is equal to 3. This cannot be equated to 0. It can't be equal to 0. In any case, p of x can never be equal to 0. Can never be equal to 0. Why means p of x is always equal to 3. So, it never has 0. The constant polynomial cannot have any zeros. Real number is a 0 of the 0 polynomial. Example, p of x is equal to 0. So, whatever the value you give for x, the polynomial will be always equal to 0. Let me take an example. This can be written as 0 into x to the power of whatever it is, x to the power of 1. It can be written as 0, x to the power of 2, 0, x to the power of 3, whatever it is. These are all are the equal to p of x is equal to anything. So, let me take this example, p of 1. Let me take this one, 0 into 1 square. So, it will be equal to anything into 0 is nothing, that is 0. Therefore, p of 1 is equal to 0. P of 1, let me take a p of 2. So, 0 into 2 whole square, that is also equal to 0. Therefore, all the real numbers, every real number is a 0 of the 0 polynomial. That's all. Every real number is a 0 of a 0 polynomial. Likewise, you can try for any of the values. You will get the 0. Any real number is taken. So, with the 0 polynomial, that real number will be the 0 of the polynomial. This also will be equal to 0. A 0 of a polynomial need not be a 0. it can be a real number other than 0, and it can also be a 0. That is stated in the second note. 0 may be a 0 of a polynomial. That means 0 can be a 0 of a polynomial, and the real numbers other than 0 can also be a 0 of the polynomials. Every linear polynomial has one and only one 0. Linear polynomial cannot have 2, 3 zeros. It can have only one one 0. A polynomial can have more than one zeros. A polynomial other than linear polynomial can have more than one zeros, but the linear polynomial can have only one 0. This completes the 0 of the polynomial. The second exercise of this chapter is completed.